Okay, want to just look at this specific type of equation where we have a sine x plus b cos x equals a constant. Now, of course, if that constant happens to be 0, we don't have an issue because I can move the cos x to the right-hand side, divide, end up with tan x. But if it's any other constant, I can't do that. There's two ways of approaching this. One using algebra, one using trig. Using algebra is to convert everything using t results. So here's one. 3 cos theta plus 4 sine theta is equal to 2. Well, if I let t equal tan theta on 2 and substitute in my t results. Now, a couple of things here. Because I'm now dealing with theta on 2, I'm only looking for solutions between 0 and 180 for theta on 2. But my actual equation now is a piece of algebra. Multiply everything by 1 plus t squared. I'll end up with a quadratic. There it is. 5t squared minus 8t minus 1 is equal to 0. So t ends up, well, it's not a nice answer, but it's an answer. 8 plus or minus the square root of 84 over 10, which of course does tidy up. But remember, t represented tan theta on 2. So tan theta on 2 is either 4 minus the square root of 21 on 5 or 4 plus the square root of 21 on 5. Let's now work out our possibilities for theta on 2. 4 minus the square root of 21, positive or negative?
Negative.
Okay. So tan theta on 2 is negative. Which quadrants? Just the second. Remember? We're only looking for answers between 0 and 180. So it's either going to be first quadrant or second quadrant for this. So I know I'm in the second quadrant. Okay. The acute angle, notice I made it positive so I can find the acute angle. It doesn't really matter. If you put 4 minus root 21 on 5 in your calculator and go tan, it just gives you the negative acute angle anyway. So however you work it out. 6 degrees 39. But remember, that's theta on 2. So now we double it to get the possibility for theta. Now, 4 plus the square root of 21 is positive. So this time we're in the first quadrant. So there is my acute angle, which is theta on 2. Double it, there's my other possibility. However, when we're using the t results, we have to physically check 180 degrees because the t results will never find that solution. Why? Yeah. Remember, we're letting t represent tan theta on 2. So if the solution happens to be 180, well, tan 180 on 2, tan 90. Tan 90 is undefined. So it won't find that solution for me. So if you're using the t results, you need to test, and I think I actually mucked this up, but it is, isn't it? Because sine 180 is actually 0 and cos 180 is negative 1. So it should have been negative 3 equals 2, but it still doesn't work either way, but I got lucky there. But it doesn't work. Now, people love using the t results because we're so comfortable with algebra. But I've got to tell you, this is more efficient. What the beauty of this is we can use it for other things as well. We can use it for graphing. We can actually end up using it in simple harmonic motion and things like that. But the idea is to get 2 trig functions and turn them into 1. So I'm going to get and change it into a sine function, into one sine function. How do I do it? I'm glad you asked. 3 cos theta plus 4 sine theta. I want to turn it into a sine function. Remember our friend up there, sine, cos, cos, sine. If it's the sine, it's the sine. I actually have that there. I've got something times cos, something times sine. So really what I'm saying is that, hang on a sec, sine alpha is 3 if you like. Well, if sine alpha is 3, then over here on my triangle, I'll put 3 on the opposite side, because sine is opposite over hypotenuse. Cos must be 4. So over here, I'll put 4 on the adjacent side. By Pythagoras, my hypotenuse is 5. So I've now created this little triangle. What I now do to my equation is multiply and divide by 5. because now I've got it. It works. Because if you have a look at what I've got inside the parentheses here, 3 on 5 is the sine of alpha. 4 on 5 is the cos of alpha. I have got sine, cos, sine. So I can now rewrite that as 5 sine alpha plus theta. Alpha being the inverse tan of 3/4, whatever that turns out to be. Now the reality is I never write this middle step in. I know that the coefficient of the trig function always turns out to be the hypotenuse. I don't worry about saying sine alpha is 3, which is bigger than 1. I'm really just saying the opposite side is 3. Adjacent side is 3. So the hypotenuse always becomes the coefficient of the trig function. Divide both sides by 5, and I've got a very simple equation to solve. It's simply my sine is 2/5. Now alpha, approximation over there, I've done 36 degrees 52. I'm in quadrant 1 or quadrant 2. The sine of beta I'm using for the acute angle. The acute angle would turn out to be 23 degrees 35. So in the first quadrant, I'm 23 on 35. Second quadrant, I'm 156.25. But remember, that is alpha plus theta. So now I subtract 36.52 on both sides, and I get the same answer as before. It doesn't look like the same answer as before, because notice my first one's negative. But I can fix that. I just add 360. So if I add 360, we get the same two answers that I got before. Going to do the same question, but now, hey, let's turn it into a cosine function. Oh, it's really up to you what you want to do. Sometimes, though, they do force your hand. And in the questions they say, turn it into a sine function or turn it into a cosine function. Okay. Well, this time I'm looking for the pattern cos, sine, sine. So this time, 3 will be the adjacent side because it is matching up with the cosine. So 3 will go there. Sine will now be 4. The hypotenuse is still 5. So I've got 5 times 3/5 cos theta plus 4/5 sine theta. But remember, if it's not the sine, it's not the sine. So this one's theta minus alpha. Okay, hypotenuse once again is the coefficient of the trig. Inverse tan of 4/3 this time, so the angle I get is 53.8. But now I'm saying that the cosine of what is 2/5. I'm in the first quadrant or the fourth quadrant. Cos beta equals 2/5. Beta is 66.25. So theta minus 53 degrees 8 is either 66.25 or 293.35. Add 53 on. Both of those answers are acceptable. They're in our range. So I've got them. I don't have to do anything to the answers. Here's an HSC one where it's not actually getting you to solve the equation. It's simply wanting you to, hey, can you turn these two functions into one? But it's the same idea. It's just that we're not going to end up solving an equation. So how do I do a question like this? What I do in reality is I go, okay, root 3 sine 3t minus cos 3t. Angle's the same. So, well, really, I'd like it in the form sine cos sine. Bingo. Because I know it's the pattern sine cos sine. So cos is root 3, adjacent is root 3. Sine is 1, so opposite is 1. So I know the coefficient is 2. So that's what I was saying. I don't normally put the middle step in. I just write straight down. It's 2. I'm turning into a sine function. 3t minus alpha. And alpha will be the inverse tan of 1 on root 3. Well, actually, I can work that one out. That's an exact value. So there it is. 2 sine 3t minus 30. Done. I said to you this is useful because if they wanted me to draw the graph of y equals root 3 sine 3t minus cos 3t, I'd have to add the two graphs together and it's messy. But if I turn it into a single sine function, that's a lot easier to draw. I just got to draw that sine curve. Let's have a look at this one from 2003 HSC. Similar sort of thing. Sin x minus cos x turn it into a cosine function. Okay, so the pattern I want here is sine, well actually I want cos, sine, sine. So, well, I'll just take a negative out. It never said R had to be positive, so I can have R as a negative number if I want. Cos minus sine, sine. So for this one, both of the sides are going to be 1. Hypotenuse is root 2. So I get minus root 2 cosine of x plus alpha. If it's not the sine, it's not the sine. Another exact value of 45 degrees. There it is. Minus root 2 cos x plus 45. All right, something to play with.